So we've talked about the heat, which is a way of energy being transferred from one object to another, and the other way that energy can be transferred is through work. One type of work is called pressure volume work, and this is caused by a volume change against an external pressure. So we can look at this piston assembly here, and we've got this orange gas, and that has an initial volume. When that expands and pushes against the piston, which resists, there's some pressure there, and we see that the new volume is larger. So the volume has gotten larger, and it's pushed against the pressure. So we can see here how that would be moving an object with force through a distance. It is a form of work. When gases expand, delta V is positive. The work is the pressure times the change in volume, but because the gas is the system and the gas is doing work on the surroundings, we need the work to be negative. So we end up with this. The work here equals negative P times the change in volume. Because the change in volume is always going to be positive. The pressure has to be positive, but we need the work to be negative. This is the sort of work that's occurring inside your car engine if you have a regular internal combustion engine. So you've got a gas combusting in here. When it does that, it expands and it pushes the pistons around. And that causes your car to move. So if we have units of atmospheres for pressure and measure the change in volume in liters, we would end up with a unit here of atmospheres times liters, which is a unit of energy, but it's kind of a weird looking one. So we have this relationship between joules and atmosphere liters. So 101.3 joules is equal to 1 atmosphere liter. I don't expect you to remember that conversion, but try to remember that it exists. 101.3 joules. And that is the same number associated with the Pascal conversion to atmospheres. Atmosphere times liters. So we can do an example here. A cylinder equipped with a piston expands against an external pressure of 1.58 atmospheres if the initial volume is 0.485 liters and the final volume is 1.245 liters. How much work in joules is done? Well, they're asking us to calculate work. They're giving us a pressure and a change in volume. So work equals negative P delta V. So the change in volume is always the final minus the initial. A change in volume can be negative. You can't have a negative volume, but you can have a negative change. So we have to get these in the correct order so the sign is correct. So the final volume is 1.245 liters. The initial is 0.485 liters. .245 minus 0.485. So 0.76. I'm subtracting here. Each of these has 3 decimal places, and so the result of that subtraction should have 3 decimal places. So I'm going to put another 0 on there. That's my change in volume. And I've got the pressure of 1.58 atmospheres. So the work is negative 1.58 atmospheres times 0.760 liters. So we could do that math. We get negative 1.2008. And the unit there is atmosphere liter, or liter atmosphere, which is not the same as a joule. Train agrees with me. But we can convert. So 101.3 joules is equal to 1 atmosphere liter. I should have 3 significant figures on that. It'll round to 122 joules. Oops, I lost my negative sign, didn't I? Any questions? Pressure times volume is work. Kind of weird.